So today's lesson is over classifying quadrilaterals. So this first page is just pretty much a guide. So remember that a quadrilateral, the word quad, means four. So quadrilateral is a four-sided polygon. So we're going to first work with quadrilaterals, then we'll go to triangles. I'm going to make two videos. So parallelograms. What are some unique features about parallelograms? Well, their opposite sides are parallel and both pairs of opposite sides. So this is how we show that two sides are parallel. So if I have two pairs of parallel sides, I stack two triangles on top of each other. So this little drawing or this little diagram just means that this side is parallel to this side and that the top is parallel to the bottom. Another unique feature about quadrilaterals is that their opposite angles are congruent. So to show that two angles are congruent, I put a curved arc in the angle that is congruent. So since I have two pairs of congruent angles, for this next side, I'm going to put two arcs and say that it's congruent to this side, two arcs. So you kind of match the number of arcs. That tells me that, oh, this angle is congruent to this angle, and these two arc angles congruent to that one. And then the last really unique feature about parallelograms is that that the diagonals bisect each other. So this is one diagonal, this is the other. So the diagonals intersect right here. We're going to call this point P. And if I were to label this parallelogram A, B, C, D, I would learn something very unique. Bisect each other. Remember, bisect means it cuts it in half, or that's the midpoint. So that means that this segment AB is congruent to AP is congruent to segment PC, and segment DP is congruent to segment BP. So I would say if you were trying to prove that you have a parallelogram, the first thing that I would do is show that their midpoints are the same. Okay, show that their midpoints are the same. For a rectangle, a rectangle is a parallelogram. And so it has all the properties of a parallelogram on top of, well, you know that rectangles have four right angles. The diagonals are congruent, or their measures are equal. And if I were to prove that I had a rectangle, I would first show that's a parallelogram, and I call those parallelograms. Remember, those two lines next to each other means parallel. It's not 11. So I would show that it's a parallelogram, and then I would use the distance formula to show that the diagonals are equal. For a rhombus, you have all of the properties of a parallelogram, and all of the sides are equal. So all of these sides are congruent to each other. And the diagonals are perpendicular. So if I were to prove that I had a rhombus, I would first show that I had a parallelogram. And then I would prove that the diagonals are perpendicular using slope. Now, I could prove that all the sides were the same using the distance formula, but that's using the distance formula 1, 2, 3, 4 times when I can just find slope of two lines, okay? And then lastly, another quadrilateral that we have is a square. So if we have a square, we know that a square is first a parallelogram, and then we have to prove that it's a rectangle, and then we have to prove that it's a rhombus. And if we have a parallelogram that is a rectangle and a rhombus, by default, it is also a square. Then we have a couple of quadrilaterals that are not parallelograms. So these quadrilaterals right here are not parallelograms. So the first one is a trapezoid. So trapezoids have one pair of parallel sides. So to prove that you have a trapezoid, you just have to use slope and prove that you have one pair of parallel sides, and they're the opposite sides. If you have an isosceles trapezoid, you have to prove that you have opposite sides, one pair of opposite sides parallel. And then the non-parallel sides are congruent. Non-parallel sides are congruent or equal. So to prove that they were parallel, I would use slope, the slope formula. And then to prove that the non-parallel sides were congruent, you would have to use the distance formula. Then you have one more quadrilateral that is not pictured here. So I need to draw a picture for you. And this is a kite. A kite is a quadrilateral. The unique features of a kite, it has two pairs of congruent adjacent sides. So what does adjacent mean? Adjacent means the sides that are right next to each other. So these two sides are right next to each other, right? They share the same vertice. They're congruent. And these two sides are right next to each other. They're also congruent. They share the same vertice. Another unique feature about a kite is that the diagonals are perpendicular. So if you want to prove that you have a kite, you have to first show that you have two pairs of congruent adjacent sides. So they're not opposite sides, they're adjacent. And then second, you have to show that the diagonals are perpendicular. Okay. All right. So let's see. Let's just get into some notes. So determining the classification of quadrilaterals, we plot the given vertices, because this is actually called like coordinate proof. We guess the type of figure, and then so if we plot the coordinates and we say that it looks like a square, we have to go ahead and prove that, right? So we're going to use a slope to determine how many pairs of parallel sides. Remember that if the sides are parallel, their slopes are the same. The slope of one side is going to equal the slope of the next side. If we use slope to determine if we have right angles, remember right angles are formed from perpendicular lines. So the slope of one, I'm going to call it A over B. And then the perpendicular slope would be negative B over A. We use distance formula to prove that sides are congruent. So we're going to look at parallelograms first, and then we're going to look at rectangles, and then rhombi and squares. So for a parallelogram, you have four different methods you can choose. I always try to choose the one that's the simplest or requires the least amount of work. And I feel like using slope is really easy. So you can either show that both pairs of opposite sides have the same slope, or show that the diagonals bisect each other using the midpoint theorem. You could also show that you have opposite sides equal by using distance, but that's using distance formula 4 times. Or you could show that one pair of opposite sides is both parallel and equal. So I'm highlighting the methods that I choose most often. For proving that a rectangle is that a parallelogram is a rectangle, first remember you have to show that it's a parallelogram, and then I always show that the diagonals are congruent. For a rhombus, first prove that it's a parallelogram, and then I always prove that the diagonals are perpendicular. And then if you have a square, you show that the diagonals bisect each other, which means that it's a parallelogram. diagonals are equal, which means that it's a rectangle, and the diagonals are perpendicular, which means it's a rhombus. And if you follow that, you've already done all of that. You've already shown that the diagonals are the same, that the diagonals are congruent, and that the diagonals are perpendicular. So you don't have any extra work to do. And then methods for a trapezoid, same thing I said, make sure one side is parallel. If you have an isosceles trapezoid, make sure that you have the opposite non-parallel sides have equal measure. So we're just going to jump right in and do some coordinate proofs. So when you do a coordinate proof, you first start off by graphing your image. So E is the point 2, 1, and I always label them. F is the point 3, 4. G is the point 7, 2. And H is the point 6, -1. Then you connect your points in the order that they were given to you. So this is quadrilateral E, F, G, H. And I believe that quadrilateral EFGH is a parallelogram. And it might be a rectangle. Kind of looks like it could be a rectangle. So first I'm going to show that it's a parallelogram. So you have to write that out. First, show that it's a parallelogram and state the method that you're going to use by showing that the diagonals bisect with midpoint. So I'm going to draw the diagonals in here so you can kind of get an idea of what you're finding the midpoint of. So I need to find the midpoint of EG. So remember the midpoint formula. You just take the x coordinates, add them together, divide by 2. So 2 is E plus 7 divided by 2. And then you take the y coordinates. 1 plus 2 divided by 2. So the midpoint of segment EG, well, 2 plus 7 is 9. So that's 9 halves, or 4.5. And 1 plus 2 is 3. So 3 halves, or 1.5. Now let's find the midpoint of FH. All right, the x coordinates 3 plus 6 over 2, and the y coordinates 4 minus 1 over 2. So 3 plus 6 is 9. So the midpoint of FH is 9 halves. And the midpoint of FH is 9 halves, and the y coordinates 3 halves. So yes, this is a parallelogram by the midpoint theorem. Okay, so now let's see, and you can actually just say by midpoint, we're not going to call them theorems. So now let's check to see if it's a rectangle. So I'm going to try and show that it's a rectangle by saying that the diagonals are equal, and I'm going to use distance. So I'm going to do that over here. So I need to find the distance of EG, and I need to find the distance of FH. So the distance of EG, well, remember the distance formula, x1 minus x2. So 2 minus 7, the quantity squared, plus G, the y coordinates, 1 minus 2, the quantity squared. So 2 minus 7 is 5. So it's negative 5. So negative 5 squared plus 1 minus 2 is negative 1, quantity squared, Well, negative 5 squared is 26. Sorry, 25 plus 1 is 26. I'm getting ahead of myself. So this is the square root of 26. Let's check the diagonal and the distance of diagonal FG. So the x-coordinates, 3 minus 6, the quantity squared, plus the y-coordinates, 4 minus a negative becomes plus 1, the quantity squared. So 3 minus 6, well, that's negative 3 squared, plus 4 and 1 is 5 squared. So negative 3 squared is 9 plus 25. That equals 34, and those are not congruent. So this is not a rectangle. All right, so let's look at our second example. Our second example, we're going to graph the ordered pairs. So D is the 0.13, E is the 0.7, negative 3, F is the 0.1, negative 9, and G is the point negative 5, negative 3. All right, so I'm going to connect my points, and this shape looks like a square. So there are 3 things that I need to prove. First, Mr. Bischoff, I need to prove that I have a parallelogram. So I'm going to show that the diagonals bisect using midpoints. So DEFG is a parallelogram. You can close that door if you would, please. All right, so midpoints. Let's see. If I connect my diagonals, just so you can see, I have diagonal DF and diagonal GE. So the midpoint of diagonal DF. Remember your midpoint, x1, x2 over 2, y1 plus y2 over 2. So x1, 1, plus x2, 1 over 2, and y1, 3, plus y2 over 2. So the midpoint of DF is 2 over 2 is 1, and 3 and negative 9 is negative 6 over 2 is negative 3. So let's find the midpoint of EG. All right, so E, x-coordinate 7, G, x-coordinate negative 5 over 2, y-coordinate negative 3, plus negative 3 over 2. All right, positive 7 plus negative 5. Well, that's 2. 2 over 2 is 1. Negative 3 plus negative 3 is negative 6. Divided by 2 is negative 3. So DEFG is a parallelogram. All right, second, I need to show that it's a rectangle. I'm going to show that it's a rectangle by showing that the diagonals are congruent. Or equal using distance. Okay, so the distance of DF or D2F, well, let's see. 1 plus 1, the quantity squared. Sorry, it's 1 minus 1. It's not a negative. 1 minus 1, the quantity squared, plus 3 minus a negative, which is plus 9 squared. So 1 minus 1 is 0. 0 squared is still 0. 3 plus 9 is 12. 12 squared is 144. And the square root of 144 is 12. Let's look at the distance from E to G. So my E coordinate, let's see, 7 minus a negative 5, which is 7 plus 5, the quantity squared, and 3 minus a negative, sorry, that's negative 3. Negative 3 minus a negative, which is plus 3, the quantity squared. All right, 7 plus 5 is 12. 12 squared is 144. Negative 3 and a positive 3 is 0. 0 squared is 0, so the square root of 144 is 12. So DEFG is a rectangle. Last, I need to show that the sides are congruent to make it a rhombus, or I can show that the diagonals are perpendicular to prove that it is a rhombus. All right, so I'm going to do that using slope. So the slope of DF, well, let's see, negative 9 minus 3 over 1 minus 1. Negative 9 minus 3 is negative 12. 1 minus 1 is 0, which means that DF is vertical because my slope is undefined. Now let me find the slope of EG. So negative 3 plus 3, because minus a negative is plus, and negative 5 minus 7. Negative 3 plus 3 is 0. Negative 5 minus 7 is negative 12. So this has a slope of 0. So I have an undefined slope and a 0 slope, which means that I have a vertical and horizontal line. So DEFG is a rhombus. Therefore, quadrilateral DEFG is a square. Whoops, I didn't mean for that to happen, because it is a parallelogram, a rectangle, and a rhombus. All right, I know this is a lot. We have 2 more examples for this video. So let's do example number 3. So go ahead and plot your points. Actually, I lied. We have 3 more examples. So negative 1, 4 is S. 3, negative 2 is T. 1, negative 2 is U. And negative 3, 4 is V. So S, T, U, V. So this is a parallelogram. I just need to prove it. It is not a rectangle. I can tell by looking that the diagonals are not, well, there aren't right angles, so it's not a rectangle. It's not a square. And the diagonals are not going to be perpendicular to one another, so it is definitely not a rhombus. So we're just going to show that it's a parallelogram. So show parallelogram by diagonal midpoints, right? Because if it bisects each other, they have the same midpoint. So I need to find the midpoint of SU, and I need to find the midpoint of TV. So let's see, SU, negative 1 plus 1 over 4 minus 2 plus a negative. So, oh, that's wrong. That's wrong. Stop. Sorry. I have too much going on. So negative 1 plus 1 over 2 and 4 minus 2 over 2. So negative 1 plus 1 is 0. 0 divided by 2 is 0. 4 minus 2 is 2. 2 divided by 2 is 1. Let's find the midpoint of TV. So 3 minus 3 over 2 and negative 2 plus 4 over 2. So when I simplify those, I have 0 over 2, which is 0, and 2 over 2, which is 1. So quadrilateral STUV is a parallelogram because the diagonals have the same midpoint, which means they bisect each other. Okay. So for example 4 and example 5, we have to find the missing point to prove that the quadrilateral is the shape named. So for the parallelogram, I need to find the missing coordinate. So remember that parallelograms have two pairs of parallel sides. So if I can find the slope of this side, I know that the other side has the same slope. And if I can find the slope of this side, the other side has that slope as well. So let's count some slope first off. So this side goes up 1, 2, 3 over 1, 2, 3. So this has a slope of 1. So this also needs to have a slope of 1. So I'm going to go down 1, 2, 3 over 1, 2, 3. So I believe that my missing point is the ordered pair 0, 1, but I want to check with the slope from this side. So if I count the slope on the top, it looks like I go down 1 over 1, 2, 3, 4, 5, 6. Let's try it again. Down 1 over 1, 2, 3, 4, 5, 6. So the missing point is 0, 1 because both sides now have same slopes. The last one needs to be a rectangle. So I'm going to use the idea that the opposite sides are congruent. So this side has a distance of 1, 2, 3, 4, 5, 6. So the opposite side also has to have a distance of 1, 2, 3, 4, 5, 6. So the missing point is the ordered pair -4, -8, because both pairs of opposite sides are congruent or equal. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. They're each 6. So this square is actually also a rectangle. Okay. So your homework is to, actually, I'm going to do another video for this. You're going to have 2 videos for today's lesson. 2 videos.